Hey guys, welcome back. Today we are going to be talking about multi-step inequalities. That will be the next step through your journey of solving linear inequalities. So, if you remember how to solve multi-step equations, and you know that solving inequalities is very similar to solving equations, and you've done really well with solving multi-step equations, then you should have almost no trouble with this at all. Now, we'll warn you that along with the catch with dividing by negative numbers to solve inequalities, or multiplying for that matter, there is another catch. But we're going to get to that when we talk about solving inequalities with variables on both sides. Right now, we're just going to stick with two-step inequalities, like this one. Alright, so remember the rules? It's the opposite of PEMDAS. Meaning instead of doing multiplication or division first, we do addition or subtraction first. So we add 9 to both sides to isolate the x term. 3 plus 9 equals 12. And then we have to divide each side by 3. X is greater than 3. Alright? Now, many teachers are going to ask that you graph the solution to the inequalities. So we're going to do it. It was 3, right? And then it's greater than, so we have to do an open circle at 3, shaded to the right. Pretty simple. Alright. Now why don't you try them? This time I'm going to ask that you remember the rules with solving inequalities with negative numbers. Alright, so negative 2x plus 4 is less than or equal to 4. Why don't you pause the video and try to work this out by yourself? Alright, so if you didn't get this, then we're going to work through it, okay? Alright, so remember, addition or subtraction first. We have addition here, so we need to subtract 4 on both sides. We should have negative 2x is less than 0. Alright? Now remember, you can't keep the symbol when dividing by negative numbers. Numbers. I provided a good check about why this is the case in my video on simple inequalities. You might want to check that. Heck that if you don't believe me, okay? But anyways, we need to flip the sign and divide each side by negative 2. Really, what's the case? Well, of course, the case is the x by itself. And then, once we flip the symbol, we should have x is greater than or equal to 0. Alright. Fairly simple graph. So we need to do a closed circle at 0 because x can be equal to 0. And then we need to shade to the right. Excellent. That is how. Now why need to do some more advanced stuff? Hopefully you know about the distributive property. I did a review of the distributive property in my video of multi-step equations if you feel like you're struggling, okay? Alright, so we're going to try this smooth. 3x plus 2 is less than 7. Let's just say that. Alright? So remember, in order to solve the equation, we need to distribute first. So imagine that this is your coefficient, and your variable term is everything that's in parentheses. The 3 multiplies to everything in the parentheses. So we're going to use 3 times x equals 3x. 3 times 2 is 6. So less than 7. Subtract 6 on both sides, we get 3x is less than 1. Divide each side by 1/3, you should have x is less than. Oh, divide by 3. I literally just gave the answer away. But yeah, that was just a bounty anyways. So x is less than 1/3. Or 1/3. I'm going to try to graph the solution with fractions. This is how I'm going to do it. 0, 1/3. Okay, that's a terrible 3, guys. I'm sorry. Okay, apparently my computer is just not responding. Okay, there we go. So x is less than 1/3. Open circle, shade to the left. There you go. Alright, try one of those advanced ones on your own now. How about 3x plus 2, 4x, x minus 1 equals 76. Okay, try it on your own. Oh, not 76, 75. Sorry, guys. Guys. Alright. Pause the video, work this out on your own, come back when you've done everything. Okay? You ready to solve? Alright, so we're using the distributive property again, so we're going to set 3x to the side here. 2 times 4x equals 8x. 2 times negative 1, because it's a subtraction sign, we have 2. Negative 2 minus 2 equals 75. We need, ooh, big mistake. Sorry, guys. I should probably add a greater than or equal to sign here. Okay. Alright. So we're going to do 11x minus 2 is greater than or equal to 75. Add 2 to each side. You should have 11x is greater than or equal to 77. Divide each side by 11. X should be greater than or equal to 7. Alright. Sorry I made a little mishap on you guys just right now. Right now. I easily get confused with equations and inequalities. If you feel the same way, I understand you. I do. But that is why it's always important to check your work, guys. Alright, so x is greater than or equal to 7. We need to put a closed circle here. And then shade to the right. And there you have it. Alright. You saw inequalities with variables on one side. Want to try 2 sides? I don't care if you do. Because, well, you're going to need this information. Alright. So how about 2 times 4x? How about 4x minus 3 equals 3x minus 4. Alright. Ooh, no. We want greater than, no. Sorry, guys. Less than or equal to 3x minus 4. Because I want to keep variables on the left side, Alright, I'm going to make sure that alright, I'm going to subtract 3x on both sides. You can take either way, but just know that you're going to need to check your work thoroughly, or at least you take the path. So that anyways, here's your results after subtracting 3x. Now we add 3 to both sides. And here's your solution set. Graph it. And is a less than or equal to sign, so we need a closed circle. Shade to the left. There you go. Alright. Now you try. This time, we're going to make it more complex. 3x plus 4 is greater than negative 4x, negative 4, 2x, x plus 5. Alright, so try to work this out on your own, and then come back when you think you got it. Okay? Go ahead and try. Alright, so we need to use distributive property on two different sides of the equation, guys. I mean, inequality. Anyways, 3 times x is 3x. 3 times 4 equals 12. Equals negative 4 times 2x is negative 8x. Negative 4 times 5 is negative 20. Now notice that we're not changing the symbol here. We are not changing the symbol because even though we're multiplying by a negative number, we are making no attempts to isolate the variables at all. Okay? Please take note of that. Anyways, because I want to keep variables on the left side of the equation, I need to add 8x both sides. You should have 11x plus 12 is greater than negative 20. Ooh, this will be an ugly one. 11x is greater than negative 20 minus 12 is negative 32. Divide each side by 11. Keep the symbol. We're dividing a negative number by a positive number. If you're dividing by a positive number, you don't change the symbol. Only if you're dividing by a negative number. Not with, by. Alright. And then you get this very ugly solution of x is greater than negative 32 over 11. Now, no matter how much I do not want to do this, since it's a fraction, I still gotta graph it. We have negative 33 over 11. I'm just going to mark that as negative 3. Then we got negative 30. That is a beautiful 3. And then negative 31 divided by 11 is a greater than sign, so we need an open circle and shade to the right. Alright. So now we got one more set. Alright. Of a topic we need to talk about. So, remember when back in linear equations, when there could be no solutions, one solution, or infinitely many solutions? Well, guess what? We are going to be facing, we are going to have that case. In inequalities when you have variables on both sides as well. However, the rules are a little different. So different, as this is inequalities, not equations. So you really need to pay attention to what I'm doing here. Okay? Alright. 4x is x plus 4 is greater than 4x plus 6 plus 6. Alright? Alright? You know what to do. Subtract 4x on both sides. Say. Alright. 4 is greater than 6. Alright? So here's the rule. If you end up with an inequality with two terms on each side, an x term and a constant, and the coefficients are the same, there can be either no solution or infinitely many solutions. If you cancel the x terms out, you will end up with just two constants being compared. Now take a look here. We have 4 is greater than 6. So, is that a true statement? No, it is not. So, if you have a false statement at the very end of your work, there is no solution. No solution. Alright? Now, I want you to try to figure this out with this equation. 5x minus 5 is less than or equal to 5x minus 6. So try to work this out and tell me how many solutions this inequality has. Okay, so hopefully you work this out, and if you did it correctly, you should end up with this. Subtract 5x on both sides. You get negative 5 is less than negative 6. Is this a true statement? Why? No, it is not. Remember that a negative 5 can only has to be to the right of a number line, of a number. To be less than or equal to negative 6. And because we're dealing with negative numbers, negative 5 is actually greater than negative 6. So this is a false statement. Therefore, there is no solution. So I actually messed up. I messed up on that one. So I'm actually going to have to make you one more. Sorry, guys. Anyways, here's your final inequality for the day. 4x minus 10. Alright, now you can try this one on your own. Okay, so this time I've made sure that this one gives you a different answer than the other two they gave you. Alright, so if you subtract 4x on both sides, this should be your answer. Is this a true statement? Yes, negative 3 is greater than negative 10 because it is to the right of negative 10 if you place it on another number line. So if you end up with no x terms, but the statement that you get is true, then there are infinitely many solutions. Alright, now before we go, I'm going to show you what the graph of both of those scenarios look like. So, if you take a look here, notice that I don't have a circle and nothing shaped. This is where you have no solution at all. But then, if you shade the entire number line, you might not have a circle, but you can see that there are solutions. This means that this is a graph that shows there are infinitely many solutions. Alright, just thought I'd show you that. And that in case any of you were curious, because we didn't get to that part. Alright, many times your teachers might ask to graph every single inequality solution, and so you might need to memorize these, but if they don't require you, don't worry about them. Just know, this is just to give you an idea of what the graphs look like. Alright? Anyways, that does it for today's lesson. Guys. Guess what, guys? I'm only going to give you 2 more lessons on linear inequalities, and then we get to go to the coordinate plane. Yep, we're going to be plane. Yep. So after this, once I conclude this video, next time I start creating videos, I will be making videos on compound inequalities and absolute value inequalities. Absolute value inequalities are going to get really challenging, but if you know about compound inequalities and try to pay attention to what I study, and pretty much for every single video, then you can understand the concepts pretty well. Okay? So after we do linear inequalities, we're going to start moving on to linear functions. How does that sound? Don't worry, guys. It's pretty easy as long as you pay attention. Alright? So anyways, thank you so much for attending. Be sure to leave a like on my video and subscribe. And if you do like this video, tell your friends about them. I'd like to help anyone out as much as they can. Okay? So thanks again for watching, guys. Have a good rest of your day. See you for the conclusion.